So my name is Elliott. I'm a postdoctoral fellow in this group. So what I've been working on for the past year is developing a robotic knee prosthesis. And so in this group we like to develop technologies that sort of fix some of the deficits associated with sort of pathology, such as losing your limb or sort of stroke. So the project I've worked on is developing a bionic knee prosthesis. And so it's over here. So this particular device has some really neat properties. One, that it's motorized, so it can contribute energy to the subject while they're wearing it, and that's kind of one of the problems with traditional prostheses, is that they're passive, or they're removing energy from the subject, and this can give them energy back, which means they can walk faster or kind of go upstairs, step over steps, and things they wouldn't have been able to do otherwise. And so it also has a clutch in it that enables us to only draw power from the battery when we absolutely need to. So what it can do is when you're walking, it can almost charge itself. So it's kind of 20 times more efficient from an electromechanical standpoint than the previous state of the art. So that's kind of its claim to fame. And then I can sort of operate it from my laptop. It's connected to the wireless network, and I'm connected to it from my laptop. And I can sort of run it through a set of onboard intelligence that would look something like walking. So if there were it's kind of trying to sense the ground right now, but if it were sensing the ground, it would sort of do a behavior that looks very similar to walking, a little bit different than what it's doing now. And those lights that are shining on the front of it indicate what sort of state it's in from a sort of controls perspective, or what sort of behavior it's exhibiting. So right now it's blue, and it's exhibiting a specific behavior associated with blue, and it's trying to kick back. So then once it kicks back and it's going to go forward, it's now it's kind of it's white, and it's decelerating the leg, getting ready for the ground to contact. So that's kind of like the sort of associated with mechanical design, and we also do control systems, and so that's what I've worked on here for the past year. And then kind of on the background here you can see a subject wearing this device and walking on it. So that's a video if you can see that. And so you can see he's walking much more naturally than maybe he would be if he were wearing his conventional prosthesis. And that, as far as stuff that I've done that's outside of sort of science and engineering, when I was in sort of undergrad for 4 to 5 years, I worked in professional auto racing, so full-time. So kind of part-time I did school. I was really only at school to go to class, or to even not go to class. And then I did professional auto racing, so that was probably 40 to 80 hours a week doing that. And so that meant sort of working on like a race car that's worth something like 1 to 1.5 million, and then traveling kind of around the country. And then we raced also in Europe. So that was my undergraduate experience, was really professional auto racing, and then I did engineering on the side. And really kind of what that showed me was I really wanted to do something that would benefit people. So after you're working on $1 million race cars, they start to just be like another machine that you're working on, and they don't really do anything that helps people. So that sort of shifted my focus to biomedical aspects of engineering, and so I ended up studying sort of these types of robots.